Hey guys, sorry for the disappearance. I was quite busy these days, and yeah. So I'm gonna show you what I've done or tried to do with the formulas from the last video. So just to catch up again, we had some formulas on player, I believe. No, it's not on player. It's on enemy. Here. So we have a function that's called set stats for the enemies. So it takes two variables, the level of the player, which is based on the act the player is in. So if the act is 1, 2, 3, 4, just like the levels of play of D&D. So if the player level or act is 4, it will generate a random level between 2017, Act 3, 16, 11, 10 to 5, 5 to 1. And then we have 3 variables. So this is challenge rating. CR equal challenge rating. So you have the maximum challenge rating the enemy can be, and the minimum. The minimum would be the easy table on the enemy encounters. Let me open it for you. I think if yeah, it's gotta be easier here. CR. So your challenge rating. The challenge rating I'm looking for, I don't even know anymore. Let me check. And so yeah, here. So this is the character advancement. So you have 4 levels of play, as you can see here. And so this is the first level, the second level of play, the third level, and the fourth level. So between each of these levels, you have different difficulties for the characters and all that. If you're playing D&D, the actual game, like you'd feel the difference. So yeah. Okay, so if we go here to NetBeans, so you have the maximum, the minimum, and the CR boss. So these are the levels of play that I just showed, and then so you have the challenge rating, which is I wanted to show something and showed something else. It's fine. Here, it's the experience threshold actually, and so the challenge rating I got was based on these levels of play. So easy to hard. So the CR minimum is whatever is in this table, and the CR max is whatever is in this hard. And deadly is for the boss. So the bosses will have a deadly difficulty. All right. And what else? I'll test it out. I'll test the gameplay and all that, and maybe I should make it as easy and medium, and then the boss is hard. That deadly is pretty difficult in D&D, so we're gonna test all that out. Okay, so that's the first part of the video, and so it pretty much does the formula and all that, and it's still not applicable. But now what I was trying to do for like the past 2 days, and I managed to do the design, so I'll show you guys the design, but the logic I tried to do was wrong. Here. So here's the design. So you're gonna have like sorry. You're gonna have 3 names for the enemy. So the first name, middle name, and last name. So the way it will go is like you have the enemies, which is the last name. So this is the actual enemy and what it is. So like for example, in the game logic, when you make a new encounter, you have a enemy's string string array. So you can put anything you want for it. You can put here human. You can put here giant, for example. These are the types of the enemies, so like their class or something like that. Not really class, but they're types. So beasts are like animals. Humans can be any humanoid of any race. Giants are giants. So you have this value here, and when you make a new enemy encounter, so yeah, here on random encounter, it will generate a no, here. So when you encounter an enemy, sorry, because you have the encounters, which can be battle, rest, or shop. And so when you actually generate a battle, you encounter an enemy, fight for your life. So when it does, it's gonna generate a enemy, which is a battle. It's a battle object. So this is the battle function. No, not the object. Sorry, function. It's a battle function. It's gonna generate an enemy object. So with the enemies from the array. So just to make it more clear, recapitulating, you have the enemy arrays. So they can be of any type: beast, human, giant, whatever. And then you have this array is going to be called in the battle function. So the value of that array, so like for example beast, it's going to be randomly picked. So let's say it's picked beast. Whenever it picks beast, it's going to create a new enemy object, and this enemy object is going to be called to the battle function. So the enemy object, so here's where we're going to go for the logic I was trying to do. So for example, you have a lizard, and then it can be a feral electrified lizard, or it can be just a lizard, or it can be like a feral lizard, feral raven, whatever. It can be a giant psychogenic dog, for example, and it can be like just a fiery rat or just a cunning dog, for example. So it can have 3 names, 2 names, or just 1 name. And these are all going to be randomly picked with a weight. So and now the logic I was trying to do, at first I tried to use hash maps, and then tried using maps, but I don't think that's there's any way, or like this is like the right way to do it. I was just trying to do that so I could learn hash maps and how they work. I managed to learn it, but it's not really useful in this case. So yeah, I tried to like call to make the key of the map as the weight. So like you have like from 20 to 40, sorry, from 1 to 20, from 21 to 40. So this is like a weight 20%, this is 20%, 20%, this is 10%, this is also 10%. This will be 6%, this is 3%, and this is 1% chance of happening. So then what I would do is like I would generate a number between 1 and 100, and if the key was less than whatever key is here, it would call this thing. But of course before that I would create a chance of this first name actually being generated for the enemy. Same thing for the middle name. So let's say you have like you have a 50% chance of your enemy having one of these first names, and you also have a 50% of the enemy having a middle name. And then if they are picked, they have whatever chance is here to be picked. So here, for example, this would be in Act 1, of course. Okay. So in each act, they're going to have different weights as well. And yeah, I think that's it pretty much. And so the way I'm going to do it now, like I'm actually going to make an enemy name object, class, and I'm going to generate objects for their names. So yeah, and so we're gonna have to call here full name equal to set name, whatever it is. What's the correction? Oh, there we go. So we're gonna set full name to be set name, whatever it returns. So in this case here, it's gonna return. So it's a string return name. So we're gonna return name here. Let's set it as empty for the time being. So now we're gonna do the logic here. I'm gonna do the same thing here, but instead of using hash maps or maps or whatever, I'm gonna see if I'm gonna use either array list or just list, or either just array, a two-dimensional array that is a string. Okay, so like for example, so you'd have a two-dimensional array, and like the first one would be the weight. So let's say it's gonna be on the same logic as before. So let's say sorry. So let's say like you have whatever, how many arrays how many array values you have. So the first, like let's say you have 3 values, so you have 3% or 4 values, and each value has a 25% chance of happening. So I'd set the weight here to 25, and here I would have the name. So like for example, Pharaoh, and then I would do this. I would add to this array these values again. So the other one would be 25, and then I change here, and so on and so on. And I'm gonna see which approach is best, and hopefully it will work out. Thank you. Have a good day, guys.